One of the difficulties I'm seeing this year is that when you're classifying quadrilaterals, some of you are having difficulty telling the difference between a square and a rhombus. So let's take a look at these two quadrilaterals and see if we can determine if they're squares or if they're rhombi or if they're neither. So the first thing we need to do, as is usually the case when we're trying to figure out quadrilaterals, we want to see which of these sides are the same length as other sides. And we can either use the Pythagorean theorem or the distance formula, which is the Pythagorean theorem but more abstract, to do that. So I will use the Pythagorean theorem on one of them, and I will use the distance formula on the other, just so that you can see it both ways. So for the shape on the left, I am going to use the Pythagorean theorem. I'm going to draw triangle legs at a right angle, which I can do because this is on grid lines, and count the spaces. 1, 2, 3, 4 spaces. So that leg has a length of 4. 1, 2, 3 spaces. That leg has a length of 3. So if this is x, I can use the Pythagorean theorem. 4 squared plus 3 squared equals x squared, since x is the hypotenuse of a right triangle. 4 squared is 16, 3 squared is 9, x squared is still x squared. 16 plus 9 is 25, so x squared is 25. And conveniently, this one comes out nicely, and I get that x is 5, and that this is a 3, 4, 5 triangle, which some of you probably recognized earlier in this example. So that length is 5. I can do the same thing for each of the other triangles. I may very quickly notice, oh, this one's going to have a leg of 3 and a leg of 3, a leg of 4. So clearly, I'm going to get the same result because I'm putting the same numbers in and doing the same thing to them. This one must also be 5. I go down here. I once again get 3 and 4 as my lengths for the different sides of the triangle if I'm just counting the boxes. So it's another 3, 4, 5 triangle. This side's going to have to be 5. I only needed to do this calculation once because I was getting the same numbers here. If I were getting different numbers, I would want to make sure that they gave me the same result. And that might be a sign for me to start getting suspicious about whether or not they were the same length, and I would want to, check that by putting them in. And this one, to the surprise of no one by this point in the example, is also a 3, 4, 5 triangle. So this shape definitely has 4 equal sides. And we have 2 shapes where that might be the case. We have a square and we have a rhombus. So it's definitely going to be one of those two. To check which, I need to see if these are 90-degree angles. And the way I can do that, I can try doing that visually, but depending on whether or not my squares are squares rather than rectangles, if I'm using kind of distorted graphing paper, or how carefully I've graphed, or whether or not one was set up just to trick me and maybe it's almost but not quite a right angle, it's best to use the actual process for this, which is to check if the slopes are opposite reciprocals. So I need to see what this slope is. Well, I already have slope triangles because I was just finding side lengths. This has a slope of up 4 and over 3. This has a slope of down 4 and over 3. So I can very quickly compare those two slopes because slope triangles and triangles to find side lengths are the same triangles. So I can just multiply 4/3 times negative 4/3, and I want to see if I get -1, in which case they'd be opposite reciprocals. You may already be able to tell by doing this in your head that they will not be opposite reciprocals, but we will go ahead and check it out anyway. 4 times -4 is -16. 3 times 3 is 9, and that is definitely not -1. So this is not a square, this is a rhombus. All of the sides are the same. I've proven all the sides are the same length. But it's not a square, because that's not perpendicular. The slopes aren't perpendicular, so this angle isn't 90 degrees, and so it's not a square, it's a rhombus. So now I'll do the same thing over here. But this time I'm going to use the distance formula just so that you get an example with each. So if I'm going to use the distance formula, I start by figuring out where all these points are on the coordinate plane, which I didn't care about for this. So this is another advantage. If you don't like dealing with negative coordinates, you will always have positive numbers if you're using the Pythagorean theorem method. A is at the point 4, 7. B is at the point 3, 3. C is at the point 7, 2. D is at the point 8, 6. So now I need to see how long each of those lengths are. So I'll start with AB. Length of AB is going to be, and the way I do this is I just pick one of my points and I put it in each of its little frames, and that way I have less to keep track of. So I'll start with point A. Doesn't really matter which one I start with as long as I'm consistent. So A is 4 and 7, and B is 3, 3. So that would be 1 squared plus 4 squared, which would be 1 plus 16, which would be the square root of 17. So this side length, which did not come out nicely, is the square root of 17. And I don't need to put that into a calculator and approximate it. I can just record it as the square root of 17 and move on with my life, because I just want to see if I get the same thing on each side. So now I will try it for B, C. And that's going to be, and I'll do the same little strategy where I build my frame and fill in one point at a time. So I'll start with B. I've got 3 and 3. And C, I've got 7 and 2. Three minus 7 is -4. 3 minus 2 is 1. -4 squared is positive 16. And I once again get the square root of 17. So that's a good sign. I'm part of the way there. Let's see what happens with the next one. CD is going to be, I'll do my same little frame here. I'll start with 7 and 2. And then D is 8 and 6. And I just use that strategy whenever I'm filling these in, because it means I'm less likely to accidentally get my X's and Y's mixed up. And it just works well for me. It's totally normal to do that differently than I do. Everyone kind of has their own little ways of keeping organized. And one of the best questions you can ask yourself as you're doing a math problem is, what do I need to do to keep this organized for me? Because you may learn that you're someone who does best with different organizational strategies. And as long as those strategies still allow someone else to see your work clearly, I mean, if someone else is looking at this later, they don't even know I used that strategy. So it doesn't end up mattering if that strategy is something you need or not. It's something you can use if you need. And now I have my third side that is also the square root of 17. And I've got a sneaking suspicion about the fourth side. I'm going to go ahead and do it anyway. And it doesn't matter if I do AD or DA. I've been tracing around this way, so I suppose I should do DA. But it really doesn't matter because it's going to be the same length in both directions. 4, 7, 8, 6. And so I definitely have a quadrilateral with all 4 sides the same. So it's either a square or a rhombus. Now I need to check if the slopes are opposite reciprocals. So I can either use the slope formula or use slope triangles. I use slope triangles over here, so I'll use the slope formula over here so that once again, you can see both methods. So I'm going to use the slope formula on points AB. So slope of AB. And the slope formula is y2 minus y1 over x2 minus x1. And that's just the general formula. So for AB, that means that B is going to be my x2, y2. So that's going to be 3 on the top, 3 on the bottom. And my y1 is 4 on the bottom and 7 on the top, because 7 is the y coordinate, 4 is the x coordinate. That simplifies to negative 4 over negative 1, which simplifies to positive 4. So the slope of AB is positive 4. Now I want to find the slope of BC. I want to see if that is a 90-degree angle at BC. So BC would be, point C is a y coordinate of 2 and an x coordinate of 7, and B is a y coordinate of 3 and an x coordinate of 3, so I get negative 1 over 4. So if I want to test if those are reciprocal slopes, I would multiply 4 times negative 1/4. Well, 4 is the same as 4 over 1. So I'd get negative 4 over 4, and that is negative 1. So this is a right angle. Is that enough information? Well, it depends on how comfortable you are with all of the various facts about quadrilaterals. So it is enough information. There's no other way we could do it at this point as long as all of these are the same, which we've already checked, and one of them is a right angle. That's all we need. If you chose to check all of the rest of the angles just to be sure, you could do that. But at this point, you would probably like to be done. So remember, to tell if something is a square or a rhombus, not only do you need to make sure the sides are all the same length, you need to see if the angles are right angles. And this one is a square.